We are completing our trilogy of type-related talks where we've gone from no types to all the types with a talk from Boxy. Boxy is on the types compiler and release teams, part of the Const generics project group, and co-created the unfair Rust quiz, which my notes say you should all try. I actually tried it yesterday because I saw the notes yesterday. It really was unfair, so
Yeah.
I appreciate that. Anyway, Boxy's going to talk to us about the state of Const generics.
Okay. Okay. Wait, is the mic on? Yeah, I can hear myself. Okay, Const generics. So I've been working on Const generics for about 4 years now, and yeah, so back in 2021, when Const generics was stabilized, I started working on Const generics a little bit after that. So I had nothing to do with the original stabilization, but the original stabilization had a number of limitations with it. It didn't support all the possible use cases. It just supported the sort of minimum necessary stuff to just let you do basic operations with arrays, like storing them uh, in structs and accepting them as function arguments while being generic over the length. But there was a lot that wasn't supported. We didn't support defaulted generic parameters. Unlike types, you aren't able to explicitly infer generic parameters. You can only implicitly elide the generic arguments, which doesn't come up a lot in practice, but it's still something we should be supporting. The set of types that we let you use in const generics is limited to not very many. It's just the integer types char and bool. So I think the most common thing you use for this is just array lengths because you can't really make your own types. And maybe the biggest limitation is that we don't let you do any computations involving generic parameters in the type system for const generics. You're only allowed to use single generic parameters. Uh, so I'm going to go over each of them a little bit, what has happened with each of the features over the past 4 years. So the first one, defaulted ones, um, works exactly the same as with type parameters. This was stabilized at the end of 2021. I want to say it's the only const generics feature we've stabilized since, but I'm not actually confident in that now that I'm up here. If there is one we've stabilized, I don't remember, and it's not in this talk, so that's great. I can't remember whose talk it was, but at some point in this conference, someone was talking about how features get pushed by lots of people, and const generics is a great example of that. A lot of the people who worked on min const generics uh, no longer work on const generics, and so there's a lot of different people now, and the people who did work on this, a lot of different people. The original implementation was Julian, LQD helped a lot, Varco did a lot of the reviews, and then myself and LCNR did a lot of the stuff towards the end. Um, so that's stabilized, that's easy. The next one, this is the not being able to explicitly infer things. It's kind of hard to craft an example that doesn't use the expressions for constructing arrays, so I'm just using that because it's one of the only cases where you're forced to explicitly write out the length. So if this was if this was a type, you'd just be able to write underscore, but here we don't allow this on stable, and we would like to support this. This was difficult to support not because of design reasons, this was just difficult because of implementation reasons. It's a lot of stuff to do with the internals of the compiler. We wind up having problems where it's not necessarily clear if an underscore argument is a type or a const. In this case, it's clearly a const, but when it's more generic, just arbitrary paths, then it's not necessarily super clear. We've recently resolved that, so this feature is basically done implementation-wise, and I'm hoping we can stabilize this soon. Um, yeah. Again, those are some of the PRs that were sort of instrumental recently, and the profile pictures of some of the people who worked on it. Some of the same faces, compiler errors has helped. Camelid is somewhere in the audience, I can't see you. There you are. Indirectly helped with some of the MGCA work, which we'll talk later. The middle profile picture at the top was somebody named Void who helped with some of the refactorings recently. I have no idea, I've never seen them again. So that's that. This is about the different types of const generic parameters. Um, we don't support this code. This is code that I would quite like for us to support, and we probably should be. It's quite a common use case to want to be able to write your own enum and then be generic over the different values. Um, this feature had a lot of both implementation and design concerns. Um, Implementation-wise, it was quite difficult because it's on here somewhere. Uh, the internal representation of how we represent values in the type system contained a bunch of superfluous extra information that we don't really want to care about or need to care about, and that made things kind of, you know. And the other thing is that deciding what types should be allowed to be used in const generics is incredibly non-trivial. Uh, it's I think Ollie talked a bit about floats. Floats are kind of annoying because the equality rules around them are weird, and we probably want stuff in the type system to have like reasonable definitions of equality, which floats do not. Uh, References are annoying in the type system because uh, Ralph, I don't think you talked about this, but they're really annoying in the optem because that you can just put whatever you want behind them, and so putting them in the type system is either we store a bunch of extra stuff that's not necessary in the type system and causes equality to be weird, or we sort of lossily delete the data from the type system and then stuff doesn't round trip properly, and that's also weird. So the current implementation, we've kind of conservatively just ruled out those things, and we'll maybe come back to it at some point. Um, oh, Ralph's on there. Yeah, I put that there. Uh, I think that's from a lot of the earlier work on vouchers. Ollie's also helped a lot. You know the faces on there. Oh, Elsiana, you're on there. Okay. This is maybe one of the I don't know if it's necessarily the most important limitation, but it's the one that I've spent the most time working on. It's that we don't allow you to use generic parameters in const generic arguments unless it's a bare parameter. This has been existing unstably under the generic const expressions feature gate for like not quite 4 years. There was a lot of renames. It started off as the just general const generics feature gate, then it got split out into const evaluatable checked, I think, and then we've renamed it to generic const expressions, which is where it currently is. Um, this is a very difficult feature to support. There are so many design issues with it. There are so many implementation issues with it. Uh, and a lot of those problems came from the fact that the scope was really big. We tried to support every single expression. We tried to do everything with it. Um, and recently we came up with a design that's more limited in scope. So like how min const generics was a thing, we now have a minimum version, which I'm calling min generic const arguments. And we've been working on this for kind of almost a year now. I think it was July last year that we came up with the design. Camilla, who I've forgotten where they are, they're over there, has done a lot of the implementation work on this. Um, it's been a project goal for the past two project goals. Um, the general idea is that instead of supporting all expressions, we're going to try and just support uses of associated constants and top-level const items. This means that all of the type system rules are equivalent to the existing type system rules for types, and we really have a good understanding of how those work. It's a very well understood area. We can just copy all the rules and we know everything's fine because realistically, const generics isn't actually that different from type generics. A lot of the difficulties we've kind of handled, like there was the way we represent values is slightly different and its own unique complexity, but it doesn't really have that much impact on this feature. Um, so yeah, we have this now. Um, it's not quite in a usable state yet. It's quite far along the phase to getting an MVP though. Maybe like one or two more PRs. Camlet has a draft PR to get to the point where, uh, did I put it on here? Yeah, the bottom left one. That's Camlet's open PR currently. Once that's done, I think MGCA will be in a point where we can actually start experimenting with it. We can uh, yeah, if we can start experimenting, we can finish out the feature. Uh, when that's done, it's likely that generic const expressions will be able to be more properly implemented. I don't know if anybody's tried using it, but you've probably run into a lot of issues with it if you have. And when this work is done, we'll be able to sort of re-implement generic const expressions in terms of the min generic const arguments design, which should hopefully work a lot better. So that's sort of all of the features that we are actually experimenting with. So um, I realize I forgot to say any of the feature gate names. That's fine, you can figure that out. So there are some things that we don't currently have feature gates for that are sort of often requested for us to experiment with, but we're not currently doing it. One difference between constant type generics is that if you have a type parameter, there's kind of an infinite set of possible arguments that people could call it with. We don't really have the concept of sealed traits in the compiler, so even if you can seal a trait and then only have a limited set of implementers, that's not really something we do anything with. So for this purposes, it's kind of like type arguments. You could have many of them. Whereas with const generics, there's a limited set. We know every single argument you could give to a bool, a const b bool. And so something that kind of arises there is if you have an impl and you're generic over a const generic parameter, sometimes people ask us if they can manually implement every single generic argument differently and then use the impulse from a generic context where they just have some generic const b bool. This is very similar to specialization. We don't currently have a feature gate for this just because it's very difficult to support. I don't really know how we do it. There's a lot of, it would take a lot of capacity that's otherwise being spent on things like MGCA. And also just design-wise, it has so much overlap with specialization that I feel like we need more experimentation with specialization first before we sort of dive into a conflicting feature. And then the other thing we don't support that's often requested is people want to write bounds like where n is greater than 10 or something like that. The generic const expressions feature kind of lets you do this just because it happens to be really powerful and do everything, but it's not really a special bound. It's just you can do it because you can put arbitrary constants in the type system. And so something that sometimes come up is that people would like to just be able to write these bounds directly. And something that's kind of interesting about that is that we kind of already have a way to limit the set of values you can pass to a function. That's just types. So if you want to write where n is greater than 10, we don't have a greater than 10 usize type in the standard library, but we do have a non-zero type. So if you wanted a greater than 0 const argument, you could just use a non-zero usize if we supported that in const generics, which we will eventually. And similarly, Ollie's pattern types talk, you could see how there might be a connection there. How you could have a const generic parameter which was const n, and then usize is like 10 dot dot, and then you get your greater than 10. I don't know how that. There might be a bit of a bootstrapping problem there if pattern types wants to use const generics to, I don't know, pattern types is hard. Yeah, we will probably come back to these at some point when there's more capacity and whatnot. There's no Lang team consensus on any of this, by the way. This is unstable experimentation that all needs to be stabilization reported and FCP'd and whatnot. So if there's anything you see and you're kind of concerned, or you're like, hey, actually, I would like this use case to be considered, like there's still time, come find me. But that's the end of the talk. I don't know how long that was. It felt kind of fast. I maybe should have done more.
I am pleased to say that you are dead on time
Really?
to allow a little bit of question time. So,
Awesome.
does anybody have questions for Boxy? All right, I'm coming your way.
So with const generics, one of the questions is we migrated a lot of the standard library types over from these macros with up to 32, but we left out the default. And I think 30 has a similar issue there that they can't specify that the trait can't be or doesn't need to be implemented for the 0, right? Do you have a solution for that?
I don't think I understand what you said. Can you say it again?
So with default and with the 30 deserialized and serialized, we have for arrays sized 0. we don't require the type T to be serialized and deserialized, right? And for anything which is greater than 0, we do require this, right?
Oh, yeah, right. So that's also a problem in the standard library. I think that might have been what you said. I can't remember what. It's default. Yeah, we messed that up with default. I honestly don't know what we're gonna do there. It's unfortunate because we kind of would eventually like, for example, default to be implemented for all lengths of arrays, and we currently can't do that because it's special cased for 0. Maybe that's a thing that's solved by some kind of specialization, but honestly, I don't know. It might maybe just work if we, when we support more kinds of const generic types, maybe we can accept like a usize that's greater than 0 and then somehow figure it out. But that kind of goes into the same thing of like this starts feeling like specialization, and it's definitely a problem that needs to be considered. But also, I don't think that thinking about this is something that necessarily blocks the other work. So it's something that I'm kind of trying to get the other stuff out the door because there's a lot of value to be had there. And then it's like, okay, how do we deal with this thorny problem that's kind of up in the air?
Thank you.
Okay, anyone else? Okay, all on the other aisle, of course. Run, Adam, run. Okay, put your hands up again, please. Right, perfect. You're in the same row. Even better. Let's start this.
Okay, I have a question about well-formedness. So I recall that it used to be the case where if you have generic const generic expressions, you have to put this weird unit array of certain lengths, and the length being the const that you want to use in a word bound, so that it implies well-formed. So I just do a quick check. It looks like this check has been gone. Is it moved to monomorphization time because we already have the array being too large issue, or what's the update on it?
Okay, so in generic const expressions, because we allow arbitrary expressions, they can panic post-monomorphization, so we get post-mono errors unless we try to design our way out of this problem. The current solution that GCE does is that we require all generic const arguments to be put in the type signature somewhere, so that the caller knows that this const argument exists, and then it can check if it's fully concrete, and then evaluate it, and then the error is no longer post-monomorphization. With min generic const args, by not allowing as many expressions, we sort of just know by construction that there's not going to be any issues post-monomorphization, at least nothing worse than types already have, which for the most part don't have post-mono errors except some really fringe cases. It's one of the things that's nice about MGCA is we can punt figuring out the sort of exact details of how we want post-mono errors to interact here. A full generic const args / when we rewrite GCE to be in terms of MGCA, that's a lot of acronyms, then we'll probably wind up with something there which is still, once again, a bit up in the air, but yeah, MGCA is free of that problem, and that's a big win.
Bit of a meta question. You showed an example with enums variants being able to be used, like you specify a const enum bound and yes, perfect. Okay. Yeah, that one. This seems, first of all, like a wonderful feature. Second, it seems like there's a significant design space, both from an implementation perspective and also from like a what does this look in the language perspective. I'm curious what the process is for bringing something like this to real life, first in obviously unstable Rust and then eventually into stable.
So the specific case of const generics is honestly kind of weird because everything got RFC'd in like the big const generics RFC forever ago, and it kind of included a lot of stuff, and then only some of it was stabilized, and then all the stuff that wasn't stabilized stuck around as unstable features. I think it's not super unusual for us to experiment with unstable features just in the compiler without there being sort of a strong I'm not sure what the word I'm looking for is. Just kind of off on our own experimenting with features. It's not that uncommon. And then So once we've sort of resolved all the implementation difficulties, we sort of know that like, okay, this is something we could actually support. And then it's like, okay, we need to hammer out all of the design space. And like, that's sort of where like the language team comes in. So in the specific case of this feature, now that the implementation is like kind of getting there, and I'd say all of the sort of big problems with it have been resolved, the next step is like we need to like involve the lang team. We need to like make sure the design is good. I honestly don't know if it needs an RFC or not. It was in the original Const RFC, but there's been some minor divergences, but also the RFC was like 6-7 years ago. So, you know, maybe it warrants a re-RFC in general. I hope that answers your question. I just kind of rambled.
All right, that is all the Q&A we have time for, so let's thank Boxy once again.